Okay, good day. Welcome officially to this PLD learning series of Part C. My name is Topman Paul-Dike, and I'd like to express my profound gratitude to Fred Swanica, William Beaver, all of the technical and non-technical mentors of ALX who has given me the opportunity to be transformed by learning new things and getting ready to do hard things. I also want to thank my team, my precious team, the reserve team, Coach Tribe reserve team, and Coach Tribe men team, and every member of Coach Tribe. Thank you all for choosing to do hard things indeed. Okay, today we'll be talking C, and I'm going to do it in such a way that if you've not heard about C before, you might begin to fall in love with C, or you know something about C after this section. All right, so we'll begin from what is C. Let's talk about C. I'll be listing here various subtopics or various concepts that we cover. So C is a programming language, right? So what's a programming language? We're talking about a language used in giving instructions to the machine. Let me just say the computer. You want to instruct the computer. You have a computer system that's able to copy and paste it because it has instructions to do something. When I click on copy, if I click on this copy image link, it has instructions on what to do. If I move this and click here, okay, this is not my system per se, but I mean, I could change my background image. I could create a new folder because instructions have been passed to this guy. If I click on new folder, do this. If I click on change background, do this. Make certain things possible. Okay, all right. So C is just a way of communicating with the machine. We like using the word machine because it just might not be only the kind of computers laptop computer, desktop computers. There are several other things. All right. It could be a phone. It could be a machine that performs a particular task. The world you're living in now, there are machines for several things, even machines for cooking. Of those. So C is a language that can be used to instruct those things. And what they are very loyal, so they're going to listen to every instruction and do it just the way you instructed. They are very loyal. So a lot of persons refer to C as a low-level programming language. And some persons refer to it as high-level programming language. And this is my own thought. This is my own take on this. Both are correct. The reason why I say both are correct is compared to modern programming languages, C is a low-level programming language. Yes, low because it is closer. I mean, you can use it to manipulate hardware and the memory of the computer directly. This interface that you're seeing here, it was a programming language that produced this interface. Watch it, observe very well. The path to C is written here, name of a file, as a logo here, right? There is an icon here. There are some check all these arrows here. There's something here showing who has joined. There is a share button here, and the share is written. There's a small icon here, and there's a blue background here. Programming languages were used to achieve these things. Just in case you're very new to programming, because I came in with zero coding experience, zero knowledge of programming, and so I understand how that feels. So it was programming languages that was used, right? Programming languages. So there's a particular programming languages that you can use to write something like this that will appear on the web. This is a web page. This is whiteboard I'm using. This is Google Jamboard. Now there is also a programming language that makes these things to be styled the way you want it to be styled. For example, the way we have this blue and this background. This programming language is for it. Okay. If I have a website that maybe that is built for you to apply for jobs, I have to have something called database where I see people who have applied, it will be storing information about people who applied, who uploaded information about themselves, the valid ID cards, the passports, and all of those. They are saved somewhere. It's called database. There's a programming language used to handle such database, right? But C itself is okay. That's a unique um, characteristics about C. It's a general purpose language. Now, all these languages I mentioned, I gave example of, they used to do one thing or the other, and most of them do not have direct access to hardware and memory. These mouse that are moving like this, there's a driver inside this computer that's making this mouse move. These are the kind of things you do with C, right? There's a driver that's making this keyboard work, interact with the computer. These are kind of programs you write to C. Embedded systems that you're not seeing them, but you're seeing their work. You're seeing the result of their presence in a system or in an environment. Okay, so in that way, in that light, C is a low-level programming language. Then it's high level because let me do some illustration. This is how C works. Because it speaks, I mean, compared to programming languages that existed before it. See what happens. Let me do this. I'm trying to illustrate. Let me use this. I'm going to draw 3 boxes here. I'm going to illustrate human language, C language, and machine language. Duplicate these and use it. So let me see. I want to say if x is, well, let's say if s greater than, if s is greater than 3, then let's say it is okay. Otherwise, it is too small. I'm going to place all of this inside the box. And I hope this is not too small. See, this is tiny. It's come attention. Okay, we can actually have it big like this. Okay. So this is human, very human. I mean, x greater than 3 is very human. This is human language. See the way C will put it. So in C, you have something like this. I have this if I can bracket. And here, there's something like printf. Okay. And then some semicolon. I want this to be the way I want it to be. So expand the space. Okay. S. Too small. I guess I need to make this one. I can see a syntax error here already. If you don't see, don't bother. If everything see for the first time, don't bother. You'll be very fine. You'll be very okay at the end of this section. And if you're watching from YouTube, you're welcome. If you have a question, you can post just a comment. Or if you're in the live audience, there'll be time for you for question and answers. Okay. Now, machine language will look like this. Something that does not make sense to us. Now, I wouldn't write exactly how it will look like. I mean, it will be too plenty, but it will be sets of zeros and ones. This is a mistake. Sets of zeros and one. like this, and then having 0, 0, 0, 0s. So there's a language that C was named C because simply because there was a language before it that was named B. And even today we have D. Interesting, isn't it? We have D. If you know how this guy works, how this machine language works, you discover that even the word, only the word okay, we have plenty, can have binaries as much as this, because O will have its binary equivalent. K will have its binary equivalent. A will have its binary equivalent. Y will have its binary equivalent. Each of these letters will have sets of binaries, and let's not focus on that. But then I want you to appreciate this relationship between human language, C programming, uh, C language, and machine language. Right? This is why it is referred to as, it could be referred to as high level programming language because it's closer to human language. Okay. Now, how are we able to interact with the computer using language that is closer to our language, without um, speaking the computer's language? Because the computer does not understand this thing. Listen, this thing written here, this C language, the computer or the machine does not understand it. It has to be translated into the form that it understands. One quality of high programming language or high level language rather, is that it has readability, it has maintainability, and it has portability. I think I want to write that down. That is readability. That's the one quality. Some qualities. Readability, there is maintainability, and code can be easily maintainability. I hope I specify. And there is portability. By that I mean it can be ported from one place to from one system to another. It can be moved. You can move it to another system and it will work just fine. If you know about web development, you discover that there are programs you will write, or the language you will use. Some browsers will not recognize it, or the version of the language. Up to now, we've had that some browsers are yet to be EX6 compliant. Sorry if you don't know what that means. What that means to say is that you could write a program and it will work well in this computer or in this environment. You take it to another environment, it's not working again. Doesn't make sense here. But C is high-level programming languages are very portable, and C has that quality. They ported from one system to another. In fact, C has the quality more than several modern programming languages. Now, what performs this magic around here of translating our code to machine language so that the machine will understand is what we call compiler. I think I look at this, get it. Put it here. And there are several kinds of compilers. There are two things that can do this actually, either compilers or interpreters. Now, this is C, so we're not working with interpreters, working with compilers. At least for now, I've not had that C has interpreters. C is a compiled language. So the compiler, let me use the word compiler, is what translates this thing into machine language so that we don't suffer ourselves, because prior to this time we would have been doing this indirectly, putting plenty of zeros and ones just to give instructions on the computer system or to the machine. But then compiler has come. I don't need to stress myself into cram. How do we even know this? It's something called a search. ASCII. Okay, let's see ASCII table. Let's pick which one we pick now. Be clear enough. Come on. Open up. Okay. It's also gonna be funny. Can I finish again this? Yes. Good. Good. Okay. It's even smaller than I expect. No, this is not what I want. Let me zoom in. I don't think this is good enough. But if okay, let me just make an illustration and then leave it. You discover that each decimal value has the decimal values for each characters. Each characters. So, for example, I was talking about spelling, writing okay. The okay now you just look for the character under this column. No, the character under this column, and then you keep moving on until you get lowercase o. You see it? Lowercase o has a decimal value of 111, as in 111. You see? And so this 111 now you now convert it to decimal, to binary, to number in base 2. If you don't know conversion of number basis, calm down as well. Don't bother yourself. So what took me here, my dear? I was saying that this is how you don't know. If I want to write okay, I will now convert each of these letters to binary values and try to instruct the computer directly. But now I don't for myself again. I just use C. C has solved that problem. I just write with my own language, something that's taught to my language, to English language. Very close. Very close. And then the compiler will now change it to what it should be here. An example of this compiler is GCC. There are several of them because GCC is the only one I've used in my life. That's the one I've got to talk about. So GCC. So after writing your C program, you call GCC. So long as your syntax is fine, okay, and correct, it will compile it very well as well. This is a language, and language is a system of communication, and you learn the basics of the language to be able to speak it fluently, to be able to speak it well. So you learn the syntax of C, learn things that must be there, things that are key, And so the standard that is followed in C is the ANSI C or ISO C. Talking about American National Standard Institute. So they had to set up a standard for C programming so that everyone follows the standards to let so that C programming doesn't become, let's say, jeopardized or disorganized, where everyone can do what he wants to do, the way he wants to do it. So there's a standard we follow so that people who produce and sell compilers, we make the compilers comply to the standard. Right? So everyone that compiles to this ANSI C standard, the compiler will just do well, be able to recognize the syntax and the codes, and then the several standard libraries that have been produced. What do I mean by standard library? I'm talking about some functionalities that are present in C being banked somewhere, right? So one of those places is stdio.h. It's a standard. If you name, we have string.h. So I don't want to speak my own. I don't plan being very professional today. My own is, even if you are number before you came to ALX, you should be able to learn this class. That's my target. So time.h, uni, there are several of them. I don't think I know them all. Several of them, and then stdio.h. So things that are used often in C were not defined. They were not given their behavior, the way they behave. For example, this printf I used here was defined in stdio.h. Was defined as whenever they call you and give you something and put that thing in within two double quotes, print it out. Put it out. So you see, so every compiler that complies to this standard will work just fine. Just fine. Now, how do you start writing C program? What do you need? Right? There are different ways there are different setups you can have. You can have an app called Code Blocks that let them VS Code can also program with C. But then, as an ALX student, you want to get used to using the terminal. That black environment called the terminal. I have one here. This is my computer system. I customize it to have this as well to be a bit transparent. So you see it, but you see that there's a difference between my prompt and your prompt. These are things you learn when you have the opportunity to learn about shell navigation. Okay. So your sandbox is enough, is a good enough environment. It's a good enough environment. Otherwise, if you want to use your own computer system, then we have some videos for you that help you sort of vagrants. Let me show you something. On the putchar channel, on my channel, if you want to use your phone as well. Sorry about the noise. Take it out of background music. I hope my voice is still louder. Okay, this particular playlist, for example, teach you how to connect your samples to your phone, how to practice on your phone, and give your videos, how to install games on your phone, all of those. And here on the putchar channel, you have a particular video that's specifically to install what we call vagrants. Where is it now? Let's just pass it. Okay, look at it. You can install vagrant or videos. You can install Ubuntu, things like this. So we have them installed, and after installing them, you want to download the compiler. Of course, as an ALX student, it's just you want to download. You want to download it before the and what else do you need? You have to have your Git, because you want to be pushing to Git. Have it installed, have your editor installed, either doing Emacs. I like using Emacs, Emacs. So this process that you need to go through as a beginner, this is subjective to for you code by yourself, type by yourself, don't use an IDE. I think they're all for your good. They're all for your good. And you don't want to take them for granted. You don't want to ignore them. You begin yourself, you'll be missing some opportunities, a lot of opportunities. So why do we learn C? Why do we learn C? Why? Learn C. There are several things that C does that there are modern languages that can do it even more efficient, more easily. Yes, there are some things that C can do. But for example, if I want to just print, if I want to write this program now in C, some programs I want, it could be easier than another programming language. It would be much easier. If you want to, let's say, imagine developing a website with C. Okay, that's by the way. So, why now are we learning C? Well, for efficiency. C is something you want to learn because it is efficient by reason of its direct access to hardware and memory. That it is portable. It is very portable. It is the most portable language I know. I don't know whether there's another one that's more portable than it. It is portable from one system to another system. It is still working well, recognized by all of those systems. So you can write a program in another environment and take it to another environment, and it's working well. And it has wide range of applications, very wide range. I said it before that it's a general purpose language, right? And then even operating systems are written using C. Operating systems are written using C language, C programming. I told you before that this is used in writing embedded systems, Okay, it is used for game development. It is used for writing other languages such as Python, even JS into JavaScript engines. A lot of these languages are implemented in C. Java, I think Ruby as well. Ruby, even Bash. If you're new, don't be scared by these names. Don't worry. One day you'll be talking like this. I'm talking. And then another one, I don't remember now. There's not compare. So C is that important. And then C has there's this stability that C has. It has backward compatibility. Backward compatibility. Compatibility. That means if you pick a C program that was written 20 years ago with a version of C that is now, let's say, outdated or something, C can still recognize that old version and run it. So there's that backward compatibility. It's compatible with previous versions. I mean, modern versions are compatible with previous versions. And then C forms a good foundation for learning programming. You want to become a software engineer, C is a good foundation. Because becoming a software engineer is much more than becoming a software engineer. Sorry, what I'm saying. Becoming a software engineer is much more than becoming a programmer. They are two different things. You don't understand how software behaves, understand scalability, you understand several things that are core in this field, and then it makes you think out solutions. C has this attitude or this behavior of letting you do everything by yourself. It's not doing anything for you. There are some other programming languages handle some things for you. Just put a simple line, or that things will be handled within the scene or behind the scene, right? And you will not know. Under you don't know what is happening if you're not trained. If you didn't take this way through your training. Now let's talk about the structure of C program. You're still moving. You're barely getting to the point where we start coding. But we need to code the example, right? So, for the structure of C. Okay, so structure of C. Now C has this not just C program actually. C has this structure where first you put in the header file. You include the header file, and then you declare the function. So let me call it main function declaration. So you begin with the curly brace and then put the instructions here, all the code here. And after doing that, you close your curly brace. No, you have a return value. This is a main program, right? So you have a return value. So let's say return value. Okay, and after you have a return value, you don't have your closing curly brace, and this is it. This is just it. So let's take an example. There is, every C program you just might need at least one header file, that is including a library where that particular function is defined. And the most common to have, let me give you an example. The most common of them is the stdio, because your first program is really about printing something out to the external output, and that function helps us do it. If this sounds strange, calm down and follow. So I'll call this an example of a C program. Okay, so this is the header file now. I will include stdio.h. And we do this, you want to have angular brackets around them, right? Now here is the angular bracket that is not very significant. I'm just using it to illustrate syntax, but here now is significant. It's part of the syntax. When I say syntax, I'm talking about the way you have to write something. The way think about adding some characters to plain text to produce a particular result, right? Okay. So put that open curly brace. Let me make it sound like we declare our main function. Usually it's like this, by convention like this, and you're dealing with Betty. If you deal with Betty, so you want to learn how to add void here. If you don't add anything here, it will still work. Right, but let's get used to adding it. So you don't have to listen to Betty. And you add this, and then let's say the instruction is print. Usually there's a tab space here of about 8. following that is standard. So print, we are fine. Add this sign, and then so let me just add the sign yet. Let me add this question mark and put semicolon. You end every instruction with semicolon. Very important. And then let me now say return 0. That's what we return by convention, right? Let's put them to return 0. And once more, if you just do it like this and put semicolon, it will work. But just get used to doing it like this. We are children of standard, fully standard. And then I go like this and add my closing curly brace. I have a full C program like this. I have a complete C program displaying the structure. Right? My whiteboard is getting crowded. So it will make sense if you are here when I delete, if you saw this video. Right? I will put the link to this whiteboard on the description on YouTube so that you can access the whiteboard and see what happened there. See, refer to it if you want to. Okay. Now we have this. If I put this in an editor, right? What I mean by editor, anything that can type, just anything. Be your notepad, your anything at all that can type and save file in any format. Watch me, follow me closely. I say anything that can type, that can allow you type tests, put in tests, input tests, and save it in any format. That thing can write C program. Can work as an editor. So how do you now achieve that? Is by saving it with the .c extension. So .c. Okay, I've been talking for a long while. Now I want to hear you talk. .c. Oh, forgive me, I'm using my mouth, not a pen, so it's making me slow to write. How do I do this one? Maybe I should be typing. Should I type in test? So talking about file extension, I said we have. Let me keep this way. Let me just do this one more file, leave this board. So file extension. Okay, so file extension. What is file extension? That's what I'm trying to name. I'll give you one example and you give me some more. File extension tells you the format in which a file is. So if you see .c, it means the file is a C file, right? Let me give you another example. When you see .mp3, what comes to your mind? Any name at all, and I see his name and see .mp3. The next thing that comes to your mind is this is an audio file. This is music, right? So please unmute at random. Give me some more examples. Some more examples. Everybody talk. Everyone talk. Let me know those that have been active here. Those that are listening attentively. Those that are following among my live audience. Say something. .mp3.
Can we have a .jpeg?
.jpeg, very correct. So when you see .jpeg, you know it's a picture. Some more, please. Someone else. Come on, where are they? Do I have some I've got some active and proactive live audience here. Respond. Joy, you're welcome. We are taking examples of file extensions. Kinsley, are you there? Bright, are you there? Give me some examples of file extensions, please. This way. Let's make progress then. So you can have, if you see .mov, you can have let's say mp4. You can have .html. So I know you are eating or cooking. Talk to me. Yes, talk to me. Yeah, so give me examples. Give me 4 examples.
Only me, Jesus Christ. Okay, that's
Jesus Christ an extension. You say APC.
APK.
MPK,
APK.
APK. That's great. Another one.
PNG.
Oh, beautiful. Beautiful. All right, this is enough. Thank you. Thank you so much. Okay, so long that if I paste what I have here, of course, excluding this line because this is not be recognized by C, it will cause some syntax. If I paste what I have here from here down inside an editor and save it as any name of my choice, and put .c, that is how it .c, it becomes a C file. And this guy will recognize it. And of course, you need the terminal, you need that environment, that black environment that you know, to be able to compile it. And GCC has to be installed there. So if you have this installed and you have your terminal, your open environment, your text editor, right? So the text editor or the terminal, GCC, I think that's enough to write C programs. I think we're ready to write C programs now. We're ready to write C programs. I've told you about how this is called the header file. It's called the function declaration. This one is main function. I just added main here because it's the main function. It has to be int main body. This is the most common. And then the instruction. Let me invest this instruction a bit. Because that's right. That is a C. Okay, and then the return value. Any questions before we start coding? Because you are about to move into coding. We are about to write our first code. If you've written C for the first time, we are about to write our first code. All right, so I'm going to the terminal. I will copy this. I told you. And then next thing I want to talk about is keywords. Let me add it here. Keywords. Text. Keywords and data type. What I do so keywords and data types. Let me add in C. But before we talk about this, let's go and write our first program first. So here is my terminal. Maybe I should explain a few things so I don't perform magic. Yes, I have the specific for this, right? I have the specific for this. Yes, there it is, the pass C. I think I want to remove everything I have there already. I'll take this as the first section. So let's call it main.c as the cost of each. The core main program main.c, main.c, right? This is the name of the program. And if you're learning this, you should know about shell applications and information, things like that, about the shell, the going to touch that, talking about C. Now, I'm going to use Emacs. Emacs is my best, but I'm going to be doing something that looks like magic. So if I don't do E, normally if I do E, this is my computer system, this is not some sandbox something. So if I do Emacs and say main.c, it will pop out, it will give me the one with the GUI. And I don't want to use that one. Alright? So all the thing is ready. Look at it. That's popped out. Yeah, I can use my mouse. Click here to say it. That's just what I want. I want the command line where my mouse will not work. And because it's my system, see, I can even click here to place it instead of Ctrl X, Ctrl C. So because I want to get the one that will pop out in these windows. So I need to add an argument either here or at the end. Minus or hyphen or dash. NW. NW means no window. So if I enter now, it will not give me the one that stays in the terminal. Where my mouse is useless. My mouse cursor is useless. I can't click anything. Everything has to be directly command. So I can close Ctrl X, Ctrl C to close this. So I now have a script that makes this easier for me. I'm telling you so that in case you see it in my other videos in this series, you won't be surprised. I like being fast. So if I do E, main.c, it gives me these windows. That's by the way. So now let me paste what I copied from here. Now, I'm going to teach you about something called comments. If I try to compile this file now, right? If I try to compile this file, there will be an error because C does not know what this is. This is not part of it. You know why? They are not keywords. So what are you doing here? They are not instructions. So what are you doing here? You work with keywords. This includes a keyword. It's something that you must find in C. This is a keyword. It's a library. It's another library. C recognizes it. This is the header file. Yeah, so I think it's a keyword. I'm not the one defining anything. Everything you see here, the only thing that is my own is this thing. This we are fine. The rest, if I remove this double quote now, something will go wrong. If I remove this semicolon, something will go wrong. So notice I can change it to anything I want to, but I don't want to have that example there. So I'm going to take it off for now. And okay, let me do Control A, Control K, and it's gone. And let me save this. Control X, Control S. What's the name? So Control X. Look down here. Left down, left button. You see Control X, CX for Control X. So Control S. It says root this. Stay I've saved the file, right? So I'm going to open another terminal so I don't close this editor. I'll open another terminal. We are compiling it and running it. So this is the terminal here. I like to make it full screen. Let's list. We have made us C now. So to compile it using the compiler, C, we do GCC main.c, right? Of course, when we do this, by default, what will come out is another file that you can now run that is called a.out. You can see they are green colored. But if I didn't want a.out, right, I will just do this. I will do the GCC main.c and I'll put dash o or hyphen o or minus o, whatever you call it, right? Hyphen o, lowercase o, and then put the name that I want it to have. Let's say PLD. And then compile. If I list this one is here now, I now have PLD. We'll call it. Both of this PLD and this main.h have the same content because they came from the same source code. This is called source code. C files that has the .c. The one that has the code you use by yourself. Source. That's something came from. Source code. So this guy came from this source. This guy as well came from this source. So if I run the two of them, they will produce the same results. Exactly the same results. How do you run them? Dot because I'm inside this direction. // and then I put the name of the file. It runs. So look at it. We printed we are fine. Followed by my prompt. This one is called prompt. This is what you can see here. It's called prompt. Okay. It usually ends with dollar or hash. I don't want to explain that now. I don't want to go into that now. So this we are fine. I don't like the way it's printing. I want it to print like this and leave space. So what do? I'm going to add a new line character. And that is /. Come on, what is happening? Something. Okay. /n. So this thing is called new line character. This one will not print a new line. So if I save it now and go back to the terminal and compile it again, let me compile now. Because I've compiled PLD, it has replaced what is in PLD already, right? So a.out and PLD does not have the same content again. A.out is print. Look at the PLD print now. Look at it now printed where and put that guy on the next slide. Because of that new line character added. But because I did not recompile the a.out, it will still print the other way. Except I go here and recompile it. So a.out and then run it again. Now, just to lay a little more emphasis on what I said before. Now, if I cut into this file, cut reveals the content of the file, right? If I cut into main.c, you see that it makes sense to us. It makes sense to us, the content, but it does not make sense to the machine. It's not making sense to my system right now, my computer system, my PC. Okay, but that's the same way. If I cut into the one that makes sense to the computer, look at it, it does not make sense to you. It does not make sense. Plenty of characters and you wonder what all this is, all these things. You know why? The compiler has translated our code that makes sense to us and does not make sense to the machine into the machine language that makes sense to the machine and does not make sense to us. And the machine has seen this and say, okay, you want me to print we are fine on the new line, and then it did it. It's always loyal. It will do not what you want it to do, but what you ask it to do. So if you don't learn very well and you ask me to do something else, whereas you want it to do something else, you'll be doing what you ask it to do, what you instructed it to do. All right, I'm going to clear this terminal. I'll type clear here. Let's enter everything is clear. Right, let's go back to our whiteboard and talk about keywords and data types. Right. So you're moving. You're moving. All right, keywords. Okay, I think I've talked about keywords. Keywords are this is that are key. They are key. You must. This is a main file now. So this return is a keyword. You don't have right over them. But the only right you have over them is to use them the way they've been designed to be used. You don't. But here I have the right to change this thing to anything I want. I can change it to anything I want. Work for me. Work for me. Okay. Actually, what I said earlier, my mouse is useless here. Okay, this is the only thing my mouse can do. You can only highlight. You cannot delete my highlighted. You cannot do anything again. Just to highlight like this, and then maybe copy. And this one is my system, not the Emacs itself. Emacs will use shortcuts. Okay, I'm making progress. So if I change this into I love C and save it and go back here. What's that place? Compile it again. Let me run that command. Besides, hope you know that when you press arrow up, you can get the former command you use. There's no typing in a command that you used before. If you want to reuse it. That's what I'm doing here. Okay, so this is C. Let me do this one. I've compiled it. Let's run play now. It says I love C. It says I love C. So I have changed it. Nothing happened. Let me go and now change this one. This return value now. I'm trying to retire. See what happens. You don't tamper with keywords. You can see the colors didn't change. My editor gives syntax colors. I mean, it's normal. Editors give syntax colors. Colors change. So if I try to compile, I'm looking for trouble. So it tells me, hello, implicit because I say, what is retire? Ask me, what is retire? I don't know this thing. This is illegally present. What is it? So I don't have the right to put something there. There are places where I have the right to do my own thing. And I'll show you that in this program now, the only place where I have the right to do my thing is inside, is within this input. Okay? Of course, there's something called comments. Let's talk about comments. We're going to talk about the other type. Something called comments. So let me do this. So, for example, I had an example of C program up here, right? If I wanted it to run along with the program, for example, of C program. And I'll save this and go back to compile the code. It gives me plenty of errors. Sometimes you just get scared. It's a plenty. You think it's because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 34, 40, 80 errors. Sometimes it's just one thing. Just one thing. If you pay attention to this thing, well, let's not go there. You're not starting. Otherwise, if you pay attention to this, is one thing that's going to be. Don't get scared and think, what I would like to fix today to take me 4 hours. Let's just see a bug. To see a bug and fix it. Okay, let's go back to the program. Now, if I want to have this thing inside this program, the only way I can have it is to state that it is a comment. And to state it is a comment, I put / everything that's not green. Everything that is green on my editor is a comment. It might not be green on your own editor. So if I put asterisk here and put / again, it ends. Only line 1 now is green color. Show that it's a comment. There will be no trouble again. Okay. Now let's compile again. You can see it compile and it's running well. Okay. That's about comment. So if I wanted double line, if I wanted multiple line comment, I will say example of C program. I will now come here. I would like something more. I like program C. You see, indeed, C is fun. Okay, if I save this and come here and compile again, there's no trouble. You know why? You see that, okay, this is an ordinary test. This is an ordinary test. Okay, they don't have a problem with you. They are ordinary tests to it. They are ordinary tests. This is one that you see that, okay, this one's are code. This one's are instructions given to me. This one's does not concern me. It's not my own instruction. It is Betty that will be very interested in this guy. So you want to learn how to maintain Betty standard in your comments. That's something you will learn later. Okay. you will learn about it. So data types. Let's talk about data types. The best way I describe data types is like this. You have seen something like this before. Okay. Let's make it simple. So let's talk about these three types: int, char, float. These are what we refer to as primitive data type. Primitive data types in C. Alright. So we're going to find out in a short while what they are, how they work. So let's take this off. Let's have these ones on new lines. Okay. I think I want to take car. Let me position them. I think I want to bring this one down. Because int and car has to do with numbers. Right? So let's take car is referring to numbers, whole numbers. Sorry, int, right? Whole numbers. Any number that is whole. Right? Any number that is whole. So examples are 2 is a whole number, so 2 is car, 2 is int. In fact, it could be large numbers. 245 is a whole number. There's no decimal value, there's no fraction. 4, 56. These are examples of int. So float is a data type that has to do with numbers that have decimal value. So numbers with decimal value. That is just when you say data type, what is data? Data is a thing, right? Data is some piece of maybe raw, maybe processed, Okay, data is raw actually. That is raw. And usually we consider as tests, like write-ups, like tests, types. So data types of data, the type of the data. Alright, so values such as 2.0 is not the same thing as 2 in C value. They are very different. Right? You don't want to have an error by associating 2.0 with int. Not the same. So if I do 245 above 0.1, this is a float. 4.6 is a float. You can go on and give more examples. Then car, I used to say car is anything. Anything. Let me use the word any character. Any character. And of course, I mean tests. Right? So, A is a car, B is a car. Even 1 can be a car. Equal to is a car. The car. Question mark is a car. Hyphen is car. Full stop is car. Even space. Space is represented using 2 single quote like this. Put a single quote, put a space, and put a single quote. That space is a car. Art. This is going. Art is a car. Same of them. And in C programming, you don't just put car like this. You put single quotes. Put it in between single quotes. So once you put something into single quotes, it is a car. It is a car. Right? It's a character. Computer type car. Now let me give you this example. Yeah. Now 2 is not the same thing as 2, which is also not the same thing as 2.0. These 3 entities are not the same. It's a programming. Not the same. This one has single quotes. In front of it and after it, it's a character. This one has nothing covering it. It's an integer. This one has decimal points. It's a float. So this is about data types in C. I've talked about comments. I've talked about compiling and running C code. I'm going to talk about the difference between printf, puts, and putchar. I'm going to talk about escape sequence. Then I'll talk about variables in C. And I'll talk about variables in environment variables. You need to know these things. This is the reason why this thing it is best that someone in ALX teaches you. The learning is very important. You might go and watch all the videos and watch all the videos and learn see very well and even do things and come back to your project. Discover that what is happening? To be honest, you don't know anything. Okay, it's an experience that we all have had. We all had an experience. So I am being tactical with this series. I'm being tactical to teach you something that I think are basic that if you don't know it, so just pay attention. Pay attention. Pay attention. Give yourself good. Okay, now let's talk about the difference between printf, putchar, and putchar. Some call it putchar, but it means put the character in the string. So let me have this here. I want to print this up. Put it here. Okay. So by the way, int, char, and float are keywords, right? Words that are being programmed that their language of C understands what they mean. You don't want to manhandle them or use them anyhow. So you can't, except you're putting it within double quotes, like I did here. If I want to put int inside here now, there'll be no problem. I can put int here, I can put int, and put it here, if you put int. But the moment it's not inside this within this string, within that those double quotes, I'm looking for trouble. Okay, we're going to talk about here. We're going to talk about the difference between printf, puts and putchar. The S in this guy stands for string. I've never searched, but based on its character, and certainly stands for string, right? The car in this guy stands for character. So this guy prints a single character. This other guy prints a string, and adds a new line. I don't need to explain what new line is, right? So this new line from minutes ago, but I will explain what string is. Let's give it chance to you. Anything it prints wanted data. Okay. That means you can put it anyhow you want it. So that when I was putting with F a while ago, because I did not add it, it did not add it for me. But if I was using it to add the new line for me, let me add it. Because this is designed to print strings. Now what is a string? Once we have more than one character, like this, I mean, C. You know, to collect them. So when they collect them, we have something like this. B. But if you see them C. They are characters. But when you have them together, A, B, C, and have them in double quotes instead of single quotes. Double quotation marks. It becomes a string. So these are characters. And this is a string. Let me call it strings. Strings and I'll put this one here. String here. The first one is the first one have three characters. The second one has two strings. Okay. So I'm really sorry for the noise in the environment. I'm really sorry. Let's hope my voice is louder than the noisy environment. So it means that this thing I have inside printf here, this thing I have within the opening and closing brackets of printf is a string because it's double quote holding it here. It's a double quote holding it here. Alright? There's something called format specifier. I don't want to go into that now. I don't want to go into that now. Okay. So let's now try to use this guys to the work. I want to put the same thing with puts. If I put puts here, right? Let me duplicate this line and have another one. And yeah, so we what's that now? Control K, Control Y, Enter, Control Y. Let me actually do the puts. Put S. They're all from the same library. This same stdio.h we access.all. So let me make this under print by turning it into a comment. If I do double comment, it's not a comment. That is not the standard way of writing comments. See, it's not a comment. It will not run again. That line of comment. Line 11 they run. So I've said it. Let me compile. Let me even change the text here. No, let me leave it that way. I'll compile. I'm going to clear this screen. Control L, and I will compile again. And I'll run the file. So it prints I love C and added an extra line. You know why? Because naturally it adds a new line. And I'm asking to add a new line. That means I'm asking to add another line. It means if I didn't print this thing and save it and compile it and run it, it will print add another line for us. Now, why this guy only handles strings? It can handle anything. So putchar prints only one character per time. If I want to use putchar to do this second again, then you can get comments. If I want to use putchar, see what will happen. After putchar I first, I must be column. I need to copy this. C K C Y C Y C I L I space I space L O V E space C and new line. Okay, let's go. So I put this as space by putting nothing in between the single quotes. I put this as L. I put this as O. I put this as V. I put this as E. I'll leave this as a space, and I'll leave this as C. So I left C. What is happening here? Okay, C. And then this has to be a new line. So that it will give us to put on the next line. Let's put that right. Put that before. So if I go now run this code again. Did I save? Okay, I saved. Let me compile again. And run it now. See, it's producing the same results. It's producing the same results. To show that it's true that it's producing the same results, let me uncomment this one. Let me read this one. Let me comment. You see that it's going 3 times now. 3 times. Let me put space in between them. That one is for us, not for the compiler. The compiler knows which is true.
Don't sound nothing like T.
Okay, so it's saved now. Let's run it. Let's see what happens. I've compiled it again. Let's run this. I love C, I love C, I love C. The 3 guys are printing them, but see the way it's what I have to add and to format it the way I wanted. I didn't wait for it to give me, it wouldn't give me anything, it wouldn't add anything. I formatted it the way I wanted. And printf can do more complex things, of course. And then this guy, I didn't need to format anything. I just gave it a string and it printed it. This guy can only pick one by one. I just give it one by one. I gave it space. I gave it line, new line. I should give it one by one and it printed. If I try to give it more than one character here, what will happen? We should get a sandbox and find out what will happen. Right? It's good to be. It's good to work. No quotes. All right, that's that about the difference between them. Now, another thing is escape sequence. Let's think about escape sequence. What is escape sequence? Is the act of is the use of backward slash to turn a special character into an ordinary character. There are special characters, okay? I've given you an example. If you do backward slash n, it's a special character, you can't print it out. You can't print it out. The only way you can print it out is to use backward slash. Use backward slash to neutralize it, to make it neutral, make it ordinary character. What do I mean by that? Let's go. There are several special characters. This one is for new line. This one is for tab space. This one is for null bytes. Don't worry if you don't know them. Just know that they are special characters. They don't behave normal. This one is like this double quote is also special as well. You don't. If I don't put it, let's see. Come on, let me show you what I mean. Let me show you what I mean. Okay. If I don't put T inside here, it will break the tab space. Backward slash C. Let me compile this again and run it. Can you see that? There's a tab space there because it's a special character. What if I didn't want to print tab space? I really wanted to print T, backward slash T. You know what I will do? I use print sequence. Like I said, it's adding backward slash to something that is a special character, so it becomes ordinary. Now, if I do this now, it will now make this one to be special again. Let's see how that is so. Let's do it like this. Let's go and compile. I'll run it again. You can see now that you can print it like an ordinary character because I added something. And the thing that I added is that neutralized it, that made ordinary did not print. That one we hide. You understand? There are several special characters. I mean, for example, in using puts, I can print, let's say, I can print 100% here. No trouble. Let's find out. Compile. Print. That's 100%, no trouble. But I couldn't do that with printf. Let's try and see. 100%. You see, it's not compiling. It's not compiling. So I want where I can print that percent is to put a backward slash before it, because that percent sign is a special character in printf. So once I put that backward slash, that escape sequence before it now makes it not a print. Let me compile it again. Oh, if it's so, that means I need to use the sister. Okay. So it means you want me to use double of this. That's the sister. So you compile now and now the print 100%. Alright, okay. Yeah, that's like huge, but a bit different. So let's talk about another character like so if you put it before n is supposed to be ordinary, but you put backward slash before n becomes special. So to make n to be special, you use backward slash. You know, for example, if you want to do something like I made 100% on mass, right? There'll be trouble here. This might be trouble here. Then let me know how I should. Let's go and try. So compile. It refuse to compile. You know why? Now, once you put this double quote is a special character. That's why. Once you put double quote here, anywhere you put the next double quote, it will end there. So it ended here. It was expecting this crazy bracket and this semicolon here. But I did not. I was pushing this in. So it's not confused. Doesn't know what to do. What if I go and put that escape sequence out backward slash here, put it here, and put another one here. It will do these double quotes that is here, this particular double quote that is here, and this particular double quote that is here into ordinary characters, and they will not print normally. And then if this thing that is telling the other that will not print out, it will hide. That is escape sequence for you. Let's go ahead and compile and see. So we compile, we run it, you can see I'm on the middle line, right? You can see I made 100% in mass. That is that for escape sequence. And now we are moving to environment variables. Let's talk about variables. We'll talk about environment variables. Okay. Let's now put the one. Let's start off the series 100 inside. I want to talk all of these difference from here to here.
What's happening? What is everywhere?
What? I didn't get it, please.
I said there's noise everywhere.
Oh, sorry about that. It sounds like it just joined. I can't control it. I'm sorry. I can't control it. Maybe I
No
should
problem.
back. It's one of those things we see in Nigeria. Because of looking for your get power, I just want you to be busy environment. And I'm really asking everybody to have stay calm because I have hold a building. So
Okay.
sorry about that. Okay. I want to do something here. What was that? Okay, I wanted to save this 100. I want to do something. I made 100% in mass, so I'm going to do it. I need this kind I made 100%. Of course, I have to put it 2, make it 2% in mass. What if I want this 100 to be saved inside a variable? Variable is just a container, right? It's just a container. It's holding something for you. Just a container. Just a container. This is how I like explaining it. I like explaining it. If I say int, I have said that the data type is int. That is int. I explained data type a while ago, right? And I cannot give it any name I want to give it. Any name. Like I mean any name. So let me call it scope. Then if I not say equal to, if I just do this in the put semicolon, I have declared the variable. I can come to another line and say score is equal to, that is, I'm giving score a value, an initial value. We call it initializing the variable. I'll talk about two things now. Initializing the variable and initializing the variable. Value this place. I'm going to this space. I think I'm in this space. So let's go in here. Let's talk about variables. Variable in C. Okay, and then I'm talking about declaration. Or you can say declaring a variable. Declaring a variable. Okay, let's say this is stating that such a variable exists. Okay, and initializing the variable. Assigning an initial value. To the variable declared. All right. So here on my terminal online 10, I declare the variable. Online 11, I initialize the variable. I give it a value 100. You end your statement with semicolon. Always end your statement with semicolon. You see, I'll say that severally. I'm saying again. Always end the statement with semicolon. That's how the compiler reads each statement. That's how it goes to the statement. Okay. So I wish I have to make that. Okay. So here now I want to do something. I want to say I made 100%. Instead of saying I made 100%, I will say I made percentage I percent. Because percentage I is called format specifiers. That format specifiers. Like I'm doing a bit from variables, but not really. Format specifiers, but not too much. We specify the format in what something can in which data can be printed. And because it's an integer, we use percentage I to declare to denote that it's an integer. Of course, percentage D will work as well, right? So percentage I for integer and was percentage with I. I'm going to put comma here and pass as a second argument after the comma the name of the variable for where the percentage I will go and get each value, because this is like saying I made dash percent in mass. So you're saying that what you're going to put in this dash, you'll find it inside here. And it goes here and picks it and prints it out. It goes here and paste it and print it out. Now I'm going to explain further about what variable is, but let's run this code and see what is happening. And see what happens here. So I'll compile it, no error. If I now print it, look at it, I made 100% in mass. So this is me using variable. Variable is just, okay, let me explain it this way. It's like where I did this. It can be done in one line. I can put the declaration and the initialization can be done in one line. So if I can do this, exactly. So this makes me do the both in one line. I'm declaring and I'm initializing at the same time. Let's see whether this code is working here, whether it will work. So if I compile again, compile, no error. If I run it, it's running, no error. Now let's go to the whiteboard and explain what I did here. And you actually understand what variable is. So I'll copy this, go to my whiteboard, and let me duplicate this. Alright, so this is, I liken this to saying I have something inside here. So I have a container, and that container, what it can hold is food, it's only food that it can hold. And the name of that container is pot. I can give it the name I want. And inside that pot, what is inside is rice. So variables are container. You give it any name you want. The compiler is not saying the name you give it. All the compiler is saying is the container. And can hold this kind of data type that you have specified. Right? That's just it. So if you say, let me give you another example down here. If you say, okay, this thing can only hold petroleum products, so let's put petroleum products, and the name of variable is or name of the container is let's say almost say jerry can. So let's say can, okay, and what is inside this variable right now is kerosene. So what is happening essentially? What is happening here is that we have the data types here first. Data types. This is how you declare variable in C and initialize at the same time, followed by the name of variable, name of var, and then you can have this sign here, and then followed by the data, and then semicolon. This is just what is happening here. Look at this inside. It's the brackets. Yes, sir. So just it. That's just it. Let me make them all aligned. It will be fine. I'm more illustrative that way. Okay. If you have a question, you can please ask. We'll be ending shortly. I'll talk about environment variables and then we'll do some things that look magical. And then petroleum is a kind containing crazy. Alright, I think this is as illustrative as it could be. Right. I guess there's no question. Well, let's make progress. Now, this is how to declare variable, right? This is about variables. You see, so you cannot go and declare a data type of int and not give it a float value. You're looking for trouble. This will not work. Neither will you go and declare float here and give it an integer value. This will not work. This might be troublesome. I feel like trying it. We've spent plenty of time already, right? So let's move on. I think that's about the last thing except environment variable. Let's talk about the environment variable. When we say environment variable, we are saying that we could do this. We are talking about the probability of having variables on this terminal here. You can have variables on this terminal. It's simple. There are several things you can do on this terminal. You can perform arithmetics. Let's say num1 equals, let me call it 5. So if I say equal, if I say show me the content, so equal dollar is for expansion, right? Equal dollar num1 is expand num1 here. What is inside num1? It tells me it's 5. 5 gets printed. So if I now do num2, I think num2 is equal to, let's say, 4, and press enter. So if I do the same thing again, say echo and say echo num2, it says it's 4. I can say okay, echo the results of how does it work? Num1 plus num2. Let's see. So it works. You calculate them together, expanded each variable, and show that it's 9. It's 9. Right. Another thing you want to do is let me use export keyword. What does the export keyword do? The export keyword makes a variable global. What do I mean by global? What if something is global? What comes to your mind? Everywhere in that world. So in this world now, it becomes available everywhere in this system. But let's find out. Let's experiment and see how that works. Okay. And okay. Now, mind you, if I use smaller letter, it will work. It will work as well. As a matter of fact, I can pass a string as a variable. I can pass my name. So num1 has a different content from num1. What I mean is that num1 in uppercase has this. No. I didn't add the dollar sign for expansion. Has this. Whereas num1 in lowercase, add the dollar sign this. And as this Topman, my name, inside it. That way I can save a file inside it. This is our file now. Let me remove our executables. Remove a.out and remove PLD. Only have main.h here, right? So I can save my file. I can save my file inside a number, inside a variable, right? Inside a variable. Okay, so if I do, let's say, let me now use the export keyword. The other ones I did not use the export keyword. Let's see what is the difference between using the export keyword and not using the export keyword. So I want to use the export keyword to declare a variable called PLD, and I want this variable to hold the file main.c. All right, here we go. Now open another terminal. I'm going to keep them side by side. So let me have this one here. I'm going to keep this first one by my left and the new one that I open by my right. Okay. Now on this first one, you recall that if I do, let me enter the command. One is echo dollar number 5 is the result. Another one is echo dollar num2 4 is the result. Another one is echo dollar what did I just get now? PLD, right? PLD. Number 6 inside there. Let's go here now and do the same thing on this timeline. So echo dollar num1. Sorry, that's not the one I did. Num1. There's nothing inside it. Does not know any variable called num1. Echo dollar num2. Does not know any variable as such. Let's not see whether it makes this other guy. PLD. So echo dollar LD. Does not know it as well. Wow. Interesting. Okay, then this is not. I was expecting this to meet actually, but let's not do this. I don't want to confuse us. I don't want to confuse us. But this house we have several users on this system. That one that is exported, that one that is global now becomes available to several users. Several users. I hope I don't confuse anybody here now. I hope I don't. Let me sign as another user. And I have another user in this place. I have a user called authorized user. I think, am I signing in? Wait. I'm doing something wrong. I'm not doing correctly. So let me just sign in as a super user. Okay, so what happened? Why are you feeling? All right, so now I'm signing as a super user, right? Now, if I try to check for the content of one, it does not know it. Let me quickly check for the content of PLD. It doesn't know that well. I'm surprised. I expect that by reason of exporting it becomes global, it becomes more everywhere. Okay, maybe we need to figure that out. Let me try again. Okay, let me now sign out on this place. Sorry. So it didn't work as I expect. Maybe you want to figure that out. But what I want you to know is that using this export keyword to declare a variable, let's say file1, it will save the variable, whatever you put after the quality sign, it will save inside the variable. And it will work as well if you don't use this guy. So what that guy is working is to make it I can demonstrate that. I don't know what I'm not doing right. Maybe I'm not checking it well. Maybe I'm not explaining it. I think this is about it. So the last thing I want to do is to show you that now that we have inside an environment variable called PLD file, I can just see this file straight from this variable. I can just see the file from the variable straight and then what I want to name it. Name it trial. So it went inside that variable, got the name of the file, and compiled it and produced trial. And the trial is working. I made 100% marks. I can as well have a script used for me. So let me do trial now. Write a bash script. It will work. But you can do it for me. Just without stress, without trouble with that. So what is the bash script? Bash script is about. Let me use it this time. Scripts. It's about you having this first line here. We call Shivan command. Then bash and then it will be followed by the command that you want it to perform for you. Normal command that you must enter on the terminal. You have put it here. Once you put it here, I'm not doing that because of time or because I don't want to do it. Okay. So let me leave some work for you to do, right? And then after doing that, you want to come and change the mode. For example, in that bash script, what if I want to just echo the content? I want to just print the content of you can also the list put it inside that place. If I just do ls here, it will be for me. Like that. And then next thing I want to do is to make it executable by doing change mode u plus x and pass the file name script, and then it turns green, showing that it is not executable. It can now instruction cannot be carried out. Alright. So if I now do forward slash and pass it into it, it is doing what ls is doing for me. It is doing exactly what ls is doing for me. If I go there and change what the content to pwd, you know what pwd does? It can do. That's cool. So pwd and come here. If I run it now, it's doing what pwd does. If I do pwd here, it will just print something. So that's bash script. So you can put instruction in the bash script to go and find the file that you save inside a variable. And of course, that variable has to be existent. Has to be existent. Has to be existing on your target your system or the system. You can compile it and save the output inside a particular file for you. So that's that for today's session on the series The Path to C. Please, does anyone have any question? No. I don't have any game now. So if there's no question, thank you so much for being part of this section. If you have a question or you're watching the meeting, please drop it as a comment and we'll attend to you. Keep doing hard things. Thank you very much.